Hello friend, in this tutorial I would like to show you how to create a reactive REST API using Kotlin, Spring, Kotlin Coroutines and Kotlin Flows entirely from scratch. And although Spring internally uses Reactor implementation, Coroutines provide a more straightforward and a natural way of writing asynchronous and non-blocking code. Thanks to this, we can enjoy the benefits of a non-blocking code without compromising the readability of the code, which might become an issue when using Project Reactor in a more mature and complex projects. At the end of this tutorial, you will know precisely how to set up a Spring Boot free project, to work with Kotlin Coroutines, run a PostgreSQL instance using Docker, create an example database and a schema, and query and persist the data using R2DBC and Coroutine CRUD repository, and finally, expose reactive REST API with Coroutines and Kotlin Flows. When it comes to requirements, you will have to have your favorite IDE setup on your local machine. I will be using IntelliJ IDEA, and if you would like to learn how to set up it for Kotlin development, then check out my other video on my YouTube channel. Additionally, I will show you how to set up Postgres using Docker, but if you already have it installed on your local machine, then feel free to use this one. Lastly, I will be using dbeaver as a database management tool, but feel free to choose whatever you want to work with your database and to perform some SQL scripts. With that being said, let's get to work. As the first step, let's learn how to set up a fresh PostgreSQL instance using Docker and populate it with some schema and example data. In order to start a fresh Postgres instance, let's open up a command prompt and specify some Docker commands. I will be using PowerShell as I am working on Windows, but this may vary depending on your machine and preferences. Of course, please keep in mind that Docker for desktop must to be up and running. So, we'll specify the Docker run in order to create a new container and run it at the same time. I will specify some dedicated name and call it some Postgres. Additionally, we'll specify an environment variable Postgres password, which effectively will set a password for the default Postgres user. So Postgres password, and let's specify the value. I'll go with Postgres, so to login we'll use Postgres and Postgres. As the next step, let's specify port mapping with -p 5432 and again 5432. We'll instruct that Docker containers port 5432 should be mapped to the same port of our local machine. So every time we will reach to localhost 5432, we will reach out to our container. Nextly, let's specify -d. This is not necessary, but this flag allows us to run container in a detached mode. And as the last thing, Postgres. This way we specify the Docker image which we would like to use here. Let's hit enter, and if you haven't downloaded the Docker image previously, then this command may take a while, so feel free to stop for a second this video. Nevertheless, we can now verify with Docker ps whether our container is up and running, and right here we can see that it is up and the appropriate ports are mapped as well. Nextly, let's open up our favorite database management tool. As I mentioned, I will be using dbeaver edition community. And inside dbeaver, we have to create a new connection to our fresh database instance. To do so, let's click in the upper part, specify the appropriate database type. This is PostgreSQL in our case. Hit next. Let's verify the settings. As we can see right here, we have the JDBC connection to localhost 5432 Postgres, which is correct in our case. Right here we can edit the username and password. In our case, Postgres will be the value. If we are ready to go, let's test the connection. Of course, you might be prompted right here to download the PostgreSQL driver. If this is the case, then please download it as well. I am ready to go, so I need to hit finish. So we can see that we have been connected successfully, and let's click and verify what schema are created. Now let's go right here, databases, Postgres, and schemas. We can see that there is only one public schema, and what I would like to do will be add a new one. So right mouse button on the Postgres, SQL editor, new SQL script, and let's specify the following: create schema, if not exists, application. Let's hit enter. Right here we can run the command, and now when I click refresh with right mouse button on the schemas, we can see that the new schema was created. As the next step, let's introduce the company table. This will consist of 3 columns: ID, name, and the address, which will store the data about the random companies. So right here, let's go with create table, if not exists, application in order to reference to the particular schema, and company. Nextly, let's hit enter, and right here I would like to specify the ID. This should be the type serial, not null, and primary key. When it comes to the name and address, for both values I would like this to be varchar 255, not null. So let's go with name, varchar 255, not null, and the same for the address, varchar 255, not null. Of course, let's add the semicolon at the end of our command. Let's select which exactly we would like to run and hit execute SQL statement. When we open up the application tables, we can see that the company was successfully created. Unfortunately, I have no clue how to change the font right here in dbeaver, so maybe if you know, then please leave a comment, because I would like to adjust that to the font we have right here. Nevertheless, let's get back to the topic. The next table I would like to create is app user. This will contain the identifier. I would like the user to store email for the user, and this should be a unique value. Also a name, age, and we also will add the company ID, which will reference to the company table. So again, create table, if not exists, application, company. Similarly, we'll start with the identifier, not null, primary key. Nextly, let's go with the email, which will be varchar 255, not null, unique. Nextly, let's add the name, varchar 255, not null, age, integer, not null, and lastly, company ID, which will be a type big int, not null, which will reference application company ID, and we would like to add on delete cascade references application company, and let's specify which column it should reference. This will be the ID column, and on delete cascade. This way we inform Postgres that when a company is deleted, we should delete also the related rows in user table. Before we start, let me fix one thing right here. Instead of company, I wanted to specify app user. Let's run the script and figure out whether it is working. It is correct. Let's hit refresh once again. We can see that both app user and companies table are ready. So with that being done, we can populate the tables with some random data. Let's hit enter twice, and let's specify the first insert into command, insert into application, company, name and address. If we do not provide the values for all columns, then we have to specify for which columns we are passing the values. So this time I want the identifier to be generated automatically, and that's why I need to specify that I want to populate name and address only. The next one is values, and right here we can specify the value. So the first one, let's call it company 1, and the address will be address also 1. Let's put a colon, copy the row, and do the same for a couple of times. At the end, we have to remember about the semicolon. Let me change the data to 3, 4, and the same right here for the company name for 3, 2, 1. Let's select what we would like to run and execute the command. As we can see, updated rows 4, which indicates that everything is working as expected. We can verify, double check by going to company and specifying the data instead. We can see that the identifiers were generated along with our past names and addresses. Let's do exactly the same for our second table. So I will insert to application.appUser. I would like to specify the email, name, age, and company ID. Email, name, age, and company ID. Values, and just like, values, and just like previously, hit tab and specify email. So email 1@codercy.com. The name we can go with John. Age will be 19, and company ID will be 1. Colon, let's copy this value. 1, 2, 3, 4, 5, 6. The more the data, the better. We'll have the possibility to check different features. I will fix the email because this needs to be a unique value. And let's specify a couple of names because later I would like to show you how to search by name right here. So I'll add some Adam. The next one will be Piotr. Maybe the next one, let it be Maria, James, Robert, and let's go Will. Let's maybe modify also the age to have different data. And maybe this way. Additionally, I would like these users to have different companies. 3, 3, 4, 3, and again 4. Lastly, let's run the command. We can see that there were 7 updated rows and we can verify the app user. So again, let's double click on app user, and this time we can see that everything is working as expected. So at this point we have the PostgreSQL instance up and running. We have created a schema, we have created tables and populate them with example data. So we are ready to go to create our Spring application. We can do that in various ways. I will show you how to generate a new project from scratch using Spring Initializer page. In order to do so, let's open up our favorite web browser. I will use Chrome right here and type Spring Initializer in Google. Right here we can see that the first result is start.spring.io, and this is the one that we would like to go to. Let's click on this, and right here we have the possibility to configure our project. When it comes to the project type, I would like this to be a Gradle Kotlin, as we will be working with Kotlin. Language, of course, we'll select the Kotlin. When it comes to Spring Boot version, we will use Spring 303. Nextly, let's set up project metadata. Right here you can specify whatever values you want, just please do not change the packaging and Java version so that we will be on the same page. So I will go with group com_codercy. Artifact, I will go with Spring Coroutines, and description, I will remove it. As I mentioned, this is totally optional. When it comes to the dependencies, All the required dependencies we can select right here in order to work with Kotlin Coroutines. We don't have to make a visit to Maven repository, for example. The first one will search for reactive support, and this is the Spring Reactive Web, which allows us to build reactive web applications. Additionally, we will try to connect to PostgreSQL database, so we will need a driver and also the R2DBC artifact. So let me add dependencies, R2DBC, Spring Data R2DBC. This artifact provides reactive connectivity to SQL databases. And the last thing, we will need the Postgres driver. So let me find my Postgres, and this is the PostgreSQL driver, which can be used both for JDBC and R2DBC connections. If you don't want to add any additional dependencies, then let's create generate and let's download the zip package. As the next step, let's navigate to the downloads directory and extract the zip package. So File Explorer, and right here in the downloads, in my case, I will go with right mouse button, extract all, and extract to the same folder. Nextly, we will have to open up IntelliJ and import our project to IntelliJ. To do so, let's hit open right here, and right here in the downloads, let me hit refresh, and we can see that Spring Coroutines was added. Let me click OK, and let's trust the project. This step may take a while because IntelliJ is downloading all the necessary dependencies, so please feel free to stop this video and resume when everything is ready in your case. So after some time, we can see that the build is successful and we can proceed to the next steps. So as the first one, let's navigate to the main package, open up resources, and let's change the application properties extension to the YAML file. This is preferable by me. Of course, you can stick to the properties if this suits you better. Let's open up the application YAML, and all we have to do right here will be to set up the connection to our PostgreSQL database. So let's specify Spring, R2DBC, and the first thing we would like to specify will be the URL, and the following will be username and the password. When it comes to the URL, this looks a bit specific. We have to specify the driver which we would like to use. So in our case, this will be R2DBC rather than JDBC. PostgreSQL // and I would like this setup to be more configurable. So right here, we will instruct Spring to first look for environment variables, and if such an environment variable is not found, then it should go with the default value. So let's specify the environment variable name dbhost, and the default value, if it is not found, will be localhost. Localhost, the port will be 5432. When it comes to the username, let's go with username, similarly db username, and when it comes to the default value, I would like to go with the Postgres user, which is not the preferred approach when working with real-life scenarios. Lastly, let's add the password, and this time it will be db password, and the value was Postgres as well. Let's save the file, and now we can navigate to the main method and verify whether the application is up and running. So let's click on the Kotlin Spring Coroutines application and click this green icon right here in order to run the application. We can see that the net is started on port 8080, which indicates that so far everything is working as expected. As a note, if you would like to specify any environment variable in your configuration, you can go right here, save it first, and right here, let's click right here, and we can specify variables by name and values. Nevertheless, I am good with the defaults. So as the next step, let's create a new package called model and introduce classes responsible for mapping database tables. let's click right here with right mouse button, new package, and I will call it model. As the first one, let's implement the company data class. So again, right mouse button, new Kotlin class. We can scroll down to the data class and call it company. The first thing we will have to do will be to use the table annotation and specify the table name to which we should map this particular class. So, table, and as a string value, application company. As you remember, we've created a schema called application, and to reference to our particular table, we will need to use the full name right here. The next thing we will have to do will be to simply map each column to a field. So the first one will be ID. I would like this to be a long type. Nevertheless, let's keep this nullable, and in a moment I will tell you why, but for now let's add the remaining val name, string value, and the last one, address, which will be a string value as well. So, coming back to this topic. First thing we have to do here will be to annotate this field with the ID annotation. This way we'll instruct Spring that the particular field is the identifier which should be used when working with this class. And why I am making this field nullable? Well, if I want to insert the data to the database and I want the identifier to be generated automatically, then I will simply keep this field explicitly null. This way, the identifier will be auto-generated so that we don't have to care about that in our code base. That's all for this class, so let me create another one called user. So again, new Kotlin class/file, data class, and call it user. Just like previously, let's start with the table annotation and reference to application.appUser. Application.appUser. Similarly, we will create the identifier first, so ID, val ID, long, nullable type, and the default value set to null. Let's navigate right here, Alt plus Enter to import our annotation. The next fields will be as follows: val email, which will be string type, name will be string as well, age on the other hand will be integer, and company ID will be of a long type, val company ID long. Let me format Ctrl plus Alt plus L, format it one line, and basically that's all we have to do for now. Moving forward, let's create the repository package. So let me hit new package, of course on the main package, repository. And as the first one, I would like to create a user repository on the other hand. So Kotlin class, and let's scroll down to the interface and I will tell you why in a moment. User repository. So in our project, we will utilize the Coroutine CRUD repository. This is a dedicated Spring Data repository built on Kotlin Coroutines. It's nothing else than a simple interface which we can extend to customize its behavior. So all we have to do here will be simply extend Coroutine CRUD repository. Let me import this, and right here this interface requires us to specify two types. The first one will be the type of the entity we will be working with in this particular repository, which simply means that we'll specify the user class. The second one, on the other hand, will be the type of the identifier, so in our case this is a long. Of course, when working with R2DBC, there is another approach where we can work with database client, but in most cases when creating a simple repositories and pretty simple operations like searching, etc., then it's better to use this approach with Spring Data because it will help us reduce the amount of boilerplate we need to write. To show you, let's click Ctrl and now navigate on this name and click this one. and right now Ctrl plus F12. This way we list all functions inside the repository. As we can see, it comes with 15 functions responsible for operations like count, delete, find by ID, find all, and persisting data in our database. So technically, if this is all, we don't have to even create our custom user repository. Nevertheless, in this tutorial, I would like to show you two approaches how to write custom queries. Additionally, if you've ever been working with Reactor, then in a nutshell, monotty functions are replaced with suspended functions returning the type T, and instead of creating fluxes, we will simply generate flows. On the other hand, if you've never worked with Reactor, then flow return type means that a function returns multiple asynchronously computed values, and suspend functions return only a single value. So right here we can see that when saving, suspend function will return a single value of type T. Save all, on the other hand, returns simply flow. With that being said, let's get back to user repository and start implementing custom functions. One of the greatest features of Spring Data are query methods, which are nothing else than functions names which are later translated to database queries. So, for example, let's create a first function called find by name containing find by name containing, and of course it has to take one parameter name of string type. Of course, let's specify the return type, and this will be the user. Right here, let's click Alt plus Enter, and important thing, when working with Kotlin Coroutines, please always select this flow, not the one we know from Java, util concurrent. So basically what Spring Data does is translating this name into a valid query, which will search for users which names contains this particular name. When it comes to how we can create such functions and what naming conventions we should keep here, I will put a dedicated link into the description or comment section under this video. Nevertheless, in the meantime, let's create another function which will be called find by company ID, and as you might have guessed, this one will be used to find users by company identifier. Find by company ID, and right here specify the identifier company ID of a long type, which will again return the flow of users. So basically this is the first approach you can use to write a custom queries, and another one which might be suitable in more complex queries will be to use query annotation. So let's add a new function, for example, fun by email. I am making it this way for purpose to show you that this is not happening by the function name, by the query itself. Email string, and again this will later return a flow of users. Now what we have to do is to use query annotation, and as a string value we can put our query. So select all from application dot app user where email equals, and right here we will perform the binding, so we will put the name of the argument. Whatever you keep here, this way you will inject the value securely into the query. Let's check it once again. Select from application user where email equals this, and in our case this query will return one user by email. With that being done, let's implement the second one, company repository. Let's hit new, Kotlin class file, navigate to interface and specify company repository. Similarly, we will extend coroutines, CRUD repository. Of course, specify the type, and this time we will select company. Similarly, the identifier was null. I would like to add one custom function here, find by name containing, find by name containing, and this should contain string argument, and as a response this should give us a flow of company. In the meantime, I have imported the flow, please keep in mind, the one from the Kotlin X library. So at this point we have everything we need for the repository layer, and we can create service layer. Let's keep right here, new package, and call it service. The first service I would like to create will be user service, so let's click new, Kotlin class, and this time this will be a standard Kotlin class called user service. Firstly, let's annotate this class as a service to inform Spring that this particular class should be detected when auto-configuring beans. Nextly, what we'll do will be simply injecting the user repository. So private val user repository, and of the type user repository. This is our interface we have just implemented. The first function we will implement will be save user, and the logic will be as follows. Firstly, we'll try to find the user by email, and if the user is already existing with that email, we will throw the 400 bad request to user. On the other hand, if there is no user with such an email, then we will save the user to the database. So let's start with suspend function save user, and as a parameter user of a user type. As a response type, I'll go with user, which will be nullable. First thing, as I mentioned, user repository, and let's click by email and provide with the email from the request. The next thing we'll have to do will be calling the terminal operator first of null to either retrieve the first value from the flow or null. If the value is not null, we will have to throw the exception. We can do that with let throw response status exception http status but request. On the other hand, if there is no user found, we will persist. So Elvis operator user repository and save our user to the database. Nextly, let's add a function responsible for finding all users. So suspend function find all users. This will not take any parameter. It will return a flow of user. Again, let's hit import equals user repository find all. Nextly, let's add a function responsible for finding users by ID. Suspend function find by ID, ID of a long type, of course, and of course the response is a nullable type because this might happen that the user will not be found. User repository find by ID identifier. Nextly, I'll implement a function to delete user by ID. This will contain two parts. The first one to find the user, and if no user is found, then we would like to return not found. On the other hand, if the user exists, then we will simply delete him by ID. Let's start with suspend function delete by ID and pass the identifier as a long. Open up val found user user repository find by ID and specify the ID. Now, if found user is equal to null, then we'll throw response status exception http status not found. On the other hand, if it is not null, then we can simply delegate user repository delete by ID and let's delete by identifier. Again, we are using functions already implemented in Coroutines CRUD repository. Another thing we would like to do will be to update user. So again, this will be pretty similar to delete by ID, suspend function update by ID. The first one will be identifier of long, And the second one will be the requested user, and this will be of user type. As a response, we would like to get the updated user, or otherwise we'll throw an exception. So user type right here, val found user equals user repository find by ID identifier. Now return if found user equals to null, then I would like to throw response status exception HTTP status not found. Otherwise, we would like to update the user. How we can do that using the repository? Well, we can reuse the save method. Basically, the save method works in two ways. The first one, when we specify a user with null ID, it will simply result in creating a new row in our database. Nevertheless, if we specify the user with some ID, then it will update the user with that ID. So all we have to do here will be go with user repository, save, and now requested user. Let's create a new instance with identifier changed to the value of found user ID. So basically, all the changes from here will be taken just by copying this ID. Lastly, let's create two more functions to find all users by name and by company ID. Suspend function, find by company ID, long type. This will be flow of users equal, and now user repository find by company ID. I will use this function later when create a company controller to list companies with users assigned to it. Nextly, let's go with suspend function, find by name like, and now name string value, go with flow user and equals users repository, find by name containing name. Ctrl+Alt+L, formatted. So the next thing we will have to do will be implement company service. Let's click on the service, new, Kotlin class, company service, and this time this will be the logic pretty similar. So we will start with service annotation. The second thing we will have to do is inject repository private val company repository correct. The first function I would like to create will be save company. This time we don't have to perform any check, we don't have any unique constraint in our table. So suspend function save company of the type company, and as a response we would like to get the nullable company. And the repository save, let's save the entity. Next one, suspend function find all companies, and now flow of company. Again, let's import the valid class equals company repository find all. Nextly, let's add a function responsible for fetching companies by ID. Suspend function find by ID long type, either get company or null. Company repository find by ID. Just like previously, let's add a function for name search. Suspend function find by name of string value, and this will get us a flow of company equals and company repository find by name containing name value. The last two functions for delete operation and for update. Let's start, for example, with delete, suspend function, delete company by ID, identifier of a long type, and we will not return anything. Let's try to search by ID, found company, company repository, find by ID, ID. And if the found company is null, let's throw an exception. If found company equals to null, let's throw response status exception with alt enter with HTTP status not found. On the other hand, if everything is as expected, we will simply delete the company. Company repository, delete by ID and specify the ID. Lastly, let's update the company by identifier, suspend function update by company by ID. ID is long and company request is company type. As a response, let's return company. Again, let's find the company. Well, found company equals company repository, find by ID, identifier. Nextly, if the found company is null, then let's throw an exception, response status exception, and now HTTP status not found. Great. Otherwise, we will update the company. So, company repository save, and right here company request copy ID equals to ID of found company. Ctrl Alt plus L, formatting done, and let's see what's going on here. Okay, we forgot about one thing. We need to add the return type right here to fulfill the requirements of compiler. And basically that's all for the service layer. In the next step, we will implement DTOs and finally switch to controllers implementation. With that being said, let's create a new package called DTOs. DTO. In this package, we will put 5 DTOs. One for user request, second one for user response, then the same for company for request and response, and lastly for search response. Basically, when working in real-life scenarios, we can use different approaches when it comes to serialization and deserialization of data, or in simple terms, JSON to Kotlin object conversions. In some cases, dealing with model classes might be sufficient, but introducing DTOs will usually be a better approach. In our examples, we will introduce separate request and response classes, which in my opinion, let us maintain our codebase much easier. So let's start with the first one, user request. Right mouse button, new Kotlin class / file, and this will be data class. So user request, enter. Right here, we would like to let user to specify the email, name, age, and company ID. We don't want them to send us the identifier. So let's start with email, string value, name, string value as well, val age, integer, and lastly, company ID. ID, which will be long type. Nevertheless, I don't want this camel case to be present in our JSON files, so we can use JSON property annotation to specify the value which we would like to have. JSON property, and right here as a string value, we can specify the company ID in snake case. Company ID snake case, Ctrl-Alt-L, formatting done, and we can add a user response. DTO, new class, data class, user response. So this time we would like to return the ID, email, name and age. So let's start with val ID, long value, val email, string value, val name, string value as well, and lastly val age, integer value. Following, let's do exactly the same for company. So let's first create company request, data class, company request, and right here we will specify two things, name and address only. Val name string, val address string as well, and lastly company response, val ID long, val name string value, val address will be string value, and lastly the list of users, and the list will be of user response. This way each time we will return not only the company but also the users belonging to the particular company. As the last thing, I would like to introduce the ID name type response. This one will be used when searching with one endpoint for both ID and name response of companies and users. So let's go right here, create new data class, ID name type response. So first one will be ID long type, val name will be string value, and last one will be type. And let's introduce a new enum, result type. Right here I will specify the enum class called result type with two possible values, either user or company. User, company. And that's basically all we need for the DTO, so we can finally create controller package and start exposing our REST endpoints. So let's go right here, package controller, and as the first one, let's implement user controller. Class user controller. In order to register this class as a web handler, we need to annotate it with REST controller annotation. Additionally, I will add request mapping so that each request going to API/users will be handled by this class. So request mapping, and as a string value /API/users. So every time someone reaches out to localhost 8080/API/users/whatever, Spring will search for a handler responsible for handling /whatever requests in this class. Anyway, let's delete this and let's add the first function. This will be the create user and responsible for post mapping. So annotation is post mapping, and this one will be as well a suspended function. Let's go with suspend function create user. As a parameter, I would like this to take a user request, so user request, and moreover we have to annotate this with request body in order to inform Spring that the JSON payload should be converted to an instance of user request. As a response type, let's use user response, which we've just implemented. User response. So we've forgotten to do one thing. We need to inject an instance of user service. Let me navigate right here, private val user service. This is the type user service. Let's get back to our function, hit equals. So now when save user returns an object, then we would like this to be mapped to user response. Otherwise, we will simply throw an internal server error indicating that something bad happened on the backend and we weren't able to persist the user in a database. So let's start with user service and save a user. User service, save user. Nevertheless, one important thing. As we can see right here, we have the user request instance, and here we need the user instance. And here comes Kotlin to work, because I believe extension functions are a great solution for this problem. I will show you how to create an extension function which will convert this to model class. Anyway, let's go with save user. And now for the user value, we would like the user request to be converted to model by the extension function. Now let's scroll a bit. Private function user request to model. As a response type, as I mentioned, we should have the user. So let's go with this one. We have to import the appropriate one, not from the security properties, but the one from our package, and create an instance of the user, specifying the necessary fields. Email equals this email, because each time we invoke this function, we can reference to the fields. Name equals this name, age equals this age, and lastly company ID equals this company ID. Great. So what's going on here now? We can see the type mismatch error because the user type is returned. So what we have to do now will be simply map this to response in a similar manner, just like we did with user request. This time I want this function to not be private because we will reuse that in company controller. Anyway, let's implement to response and user response is the type. Navigate down, user response, ID equals this identifier. We have to keep in mind that user response has non-null long type and user has nullable long type, so we can be sure that this always will be true in this case. Email equals this email, name equals this name, and lastly age equals this age. Ctrl+Alt+L, doing the formatting. Now looks that we are almost here. Found is the nullable type, so we can make sure with simply throw response status exception and http status internal server error. Let me import the class, and now we can see that compiler is happy about our code. The next function we'll implement will be defined users. It will be working in two ways. If the user will specify additional name query parameter equals name whatever, then we would like this function to trigger defined all user by name like function in user service. On the other hand, if there is no parameter, then we'll simply return all users. With that being said, let's start by get mapping, suspend function, find all. Now let's introduce a parameter called name. It will be string nullable value. What's more important, we have to annotate this parameter with request param, which will bind the value of name parameter to our name variable. So request param, enter. Firstly, let's specify the name which user will provide. I will keep it the same. And the second one, let's set required to false because the default value is set to true. So nextly, we will expect the flow of user response to be returned, and right here, let's import the Kotlin X Coroutines flow. Instead of equals, let's go with parentheses, and now val users equals name, let user service find by name like, and we can forward the non-null name. So this means each time name is not null, we will trigger this function. On the other hand, if the name is actually null, user service find all users. Lastly, we will have to do the mapping, and for that we will use a map function from Flow. This works just like mapping from collections. Return users, and now map user to response. Let's import this function, and right here. Of course, we could do it in another manner. For example, map user to response, but this is a syntactic sugar using simple function reference. The next endpoint we would like to expose will be getMapping by ID to fetch the particular user. Again, let's go with getMapping, but this time inside it, let's specify the ID path variable, which additionally we will bind to function parameter. So let's start with suspend function, find by ID, path variable, ID, which will be automatically converted to the long type. When it comes to the response type, we will go with user response, and if the user is not found, then we will throw response status exception and return 404 not found to the user. So user response equals user service find by ID. Let's pass the identifier. Nextly, let's go with let use again user to response. And lastly, let's throw the response status exception when the user is not found. HTTP status not found. Following, let's implement the delete and update endpoints. Let's start with the first one, delete mapping. Just like previously, we will add the path variable, suspend function, delete by ID, path variable, ID of the long type, and we don't want to return anything. We'll simply trigger the user service and delete by ID, enter. Lastly, put mapping. And we'll go with the path variable ID, suspend function, update by ID, and the path variable will be ID long type. Additionally, we would like to bind the request body to user request. So request body, user request type. Of course, I would like to return the user response. So let's start with user service, update by ID. Let's forward the ID. Let's forward the user request, which we have to map to model. And if everything is succeeded, we map that to response. Ctrl+Alt+L, formatting is done, and this is basically all we need to expose user controller endpoints. And just like this one, let's implement a new company controller. Let's click right mouse button, Kotlin class, and call it company controller. Similarly, let's map it as REST controller and request mapping, which will be pointing to /API/companies. This time, let's firstly inject the company service, private vol company service, which is of type company service. Just like previously, let's start with post mapping, and create first suspended function called create company, request body, company request of the type company request. As a response, I would like to get company response. Right here, company service, save company, and again we have company request, and we would like this to be mapped into the company equals, and let's add a new private extension function, private function company request to model company equals new company, and name should be mapped to this name, address equals this address. Let's get back to save company request to model. And now if the company was created successfully, I want this to be mapped to response. So let's start with this one to response. And let's implement a new function. Private fun company to response equals company response. New company response identifier will be equal to this identifier. Of course, we have to make sure that this will be not null. Name equals this name. Address equals this address. And for users, we will have to provide a list of users' responses. Users equals, and we will have to provide this as a parameter. And as a new company will not have any users, by default I will set this to empty list. So users list users equals empty list. And right here, users map user to response. And basically that's all we need here. Let's figure out what's going on here. So just like we did previously, we will have to throw an exception in case the company was not created. Response status exception, HTTP status, internal server error, and let's import the class. Wonderful. The next thing we would like to do will be find company by name, just like previously. Let's start with get mapping, suspend function, find company, request parameter, the name will be name, required set to false, and type string nullable. As a response, we would like this to be the flow of company response. So now let's open up parentheses and search for companies. File companies equals, if the name is not null, then we would like to go to company service, and find by name and provide the particular name. Otherwise, company service and find all. Wonderful. Now, when we will be returning companies, we would like the list of users to be simply added to our response payload. To do so, let's start with return companies. And now, first mapping. So for each company, I would like this to be mapped to company response. So company to response. And for users, we would simply find company users. So let's create a new private function. Find company users. And let's forward the company. In order to create a new function, we simply can go to the definition, hit Alt plus Enter, and select Create Function Find Company Users. The parameter name is OK, type is OK, and the return type is valid as well. Now let's get rid of this to-do along with parentheses. And what we will have to do will be inject additionally user service. So let's get back right here, private val user service, and this will be of user service type. Next, go with user service, find by company ID, and let's specify the company.identifier, which will be not null. What compiler is complaining about is that find by company ID returns the flow of user, and we want to return the list of users. And all we have to do is simply run toList, which is a terminal operator. Of course, we are dealing here with coroutines, so we have to make this function suspend function. And basically, that's all for this endpoint. Nextly, let's implement get mapping to find company by identifier. Get mapping here /id and introduce suspend function, find by id, path variable id of a long type, which returns of course, company response equals company service find by ID. Let's specify the identifier. If the company is returned, we will map it and enrich the payload with associated users. So company, next line, company to response, users equals find company users for our company. Nevertheless, if the particular company was not found, then again we'll throw response status exception and specified 404 not found. HTTP status not found. Lastly, we will add delete and put mapping to our controller. So delete mapping /id suspend function delete by ID bind to path variable ID long, and we will simply invoke company service delete company by ID with particular ID. Lastly, put mapping suspend function update by ID, and this time we'll go with path variable ID of type long and request body company request of type company request. As a response, I would like to return the updated company, so company response type. Let's invoke company service update company by ID. Let's specify the ID and let's map the company request to model. Let's go with let company, and we'll have to map it to company response. So company to response, and for users we will reuse find company users. As the last touch, Ctrl+Alt+L, let's format the code, and that's basically all we need for this controller. So finally, let's implement search controller, which will contain only one function. So let's hit new, Kotlin class, search controller, and again, let's annotate this with REST controller, and additionally request mapping and /API/search. We would like to inject both user service and company service here. So private val user service of type user service and private val company service, which will be of type company service. Finally, let's implement a get mapping, and this function will be responsible for searching both companies and users by a name. So let's call it search by name. Let's start everything with request param, which will be the required parameter. Request param query, and I would like the query be of the string type. Nextly, what I would like to return will be the flow of ID name type response. So flow ID name type response, and let's open up parentheses. Firstly, let's take care of users flow. Val users flow equals user service find by name like query, and the second one, val companies flow equals company service find by name query. Nevertheless, at this point, these two return completely different responses, one with users and the second one from company. So additionally, we will again implement extension function for both user and company to convert them to ID name type response. Private function user to ID name type response equals ID name type response. Let's import appropriate user ID name type response. For the identifier, we'll specify this identifier not null, name will be equals this name, and for type equals result type equals user. Similarly, we can copy this value, maybe copy paste, and replace that with company, and this time type will be company. What we can do with these two flows, we can simply invoke in both cases a map. So map user to ID name type response. Let's import the mapping. And for company's flow, exactly the same, but using another reference, company to ID name type response. If we would like to combine together these two flows without preserving any order, then the merge operator will be the right choice here. Return merge users flow and company's flow. Ctrl plus Alt plus L, and basically that's all we need to expose a REST API using Kotlin, Spring Boot and Kotlin Coroutines along with Flows. The testing part will be your homework, but as a bonus in the description for this video, you will find a link to a collection for Postman which you can import to your program and verify if everything is working as expected. Thank you once again for watching, and if you enjoyed the content, then please leave a comment in the comment section below.